I remember very clearly my high school days where my stats teacher would tell us to find the Z value with a very big table of numbers. However, I never understood what the Z value is and why you even need to use it. I'm not even sure if my teacher actually explained it either. If you want to figure out what the point of a Z value is, join me today. Before we learn about the Z value, we must know about the normal distribution. A normal distribution is a symmetrical bell-shaped curve where most data points gather around the central mean. The normal distribution is extremely important as many variables such as IQ scores, heights, test scores, and many others all naturally form a bell-shaped curve. This also means normal distributions are used a lot to model real-life situations and to analyze data. Because normal distributions occur so frequently, calculating probabilities separately for each distribution can be complex and time-consuming. To simplify this, we use a standard normal distribution. A standard normal has a mean of 0 and a standard deviation of 1. Because the standard normal distribution is widely used, a table of its values has been developed to simplify the probability calculations. You may be wondering, since the standard normal distribution has a mean of 0 and a standard deviation of 1, how can we use its table for other normal distributions with different values? Now that is where Z values come into play. Z values transform any normal distribution into the standard normal distribution by rescaling the data. You can see here that blue, green, and red has been transformed and rescaled all to look like yellow, the standard normal. A Z value represents how many standard deviations a value is from the mean. Because every normal distribution becomes the same standard normal distribution, after this transformation, we only need one universal table of probabilities. This means that instead of calculating probabilities from scratch for every different distribution, we can simply use the Z values to look up the corresponding probability in the standard normal table. For example, if we calculated our Z value to be maybe 0.74, all we need to do is go across from here, then go down, and we would find that our probability is here. Very quick and handy, right? Calculating the Z value is actually very easy. All you need to do is use this equation, where x is your observed value, mu is your mean of your distribution, and sigma is the standard deviation. All we're doing here is measuring how far your value is from the mean, then rescaling that distance by the standard deviation, and the results tell you how many standard deviations from the mean your value sits. So if you look here, this is what rescaling looks like. We are going from this one, scaling it so that it only has a mean of 0, and then we also rescale x so that now it's sitting here. But this area is the same as this area. Once you have the Z value, you can just go to the table and find the corresponding probability, like what we had done here with this random number we made up. Ultimately, z-values simplify working with normal distributions by transforming them into a common scale, making probability calculations much more manageable. Hopefully, this has helped clarify z-values and given you a bit of a light bulb moment. If you enjoyed this video and want to see more content like this, don't forget to like and subscribe.